Hello, and today's purpose of the day is I can divide monomials. Please take a few minutes and complete the warm-up. Let's take a look at the first one. I'm going to simplify my power to a power and change that to a 6 and now distribute that to everything inside the parentheses. So 18 to the 6th power is a large number. I'm going to write this down here. 34,012,224. And then I have a to the 12th, c to the 42nd, and d to the 18th power. Okay, let's take a look at number 2, which hopefully you've already completed. If I simplify here, this really is d to the 0 is 1. So I know I'm going to have a variable d in the denominator. And then b to the 4th and b to the 2nd. If I take away b to the 2nd, I'm left with b squared in the numerator. Take away a c, so I get b squared c all over d. All right, last one here, the number 3. I'm going to distribute that 4 to everything inside the parentheses. So when I do that, I get 3 to the 4th, which is really 81, c to the 16th, d to the 16th, and f to the 12th, all over negative 5 to the 4th power is positive 625, again because I have 4 negative 5s. So those negatives will cancel out. So 5 times 5 times 5 times 5 is 625. And then I have c to the 8th, d to the 8th, and f to the 4th. So now if I simplify here, 81 over 625 cannot simplify. Nothing goes into those evenly, so I know those numbers will be in my answer. And then if I take away c to the 8th, I'm left with 8 in the numerator. Take away 8 in the denominator, left with d to the 8th in the numerator. Take away f to the 4th, and I'm left with f to the 8 in the numerator. So I'll have an exponent of 8, and that's my final answer. So we just took some time to review a little bit of multiplying monomials. Let's look a little bit more at the zero exponent property. This zero exponent property states that any non-zero number raised to the 0 power is 1. So let's take a look at a few more examples. 15 to the 0 power equals 1. b over c to the 0 power equals 1. And 2 to the 7th to 0 power equals 1. Anything to the 0 power equals 1. Now let's look at a couple of these unique examples. So x to the 5th, y to the 0 over x to the 3rd. This y to the 0 turns to a 1, but now I can continue to simplify the x's. So I'm left with x squared. 5x all to the 0 power is 1, but what's 5 times x to the 0 power? Yeah, x to the 0 power turns to 1, and what's 5 times 1? 5. So sometimes you just got to be careful on where that 0 is or what exponent 0 is attached to. Rule number 4, negative exponent property. In words, what the negative exponent property states is that for any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Also, the reciprocal of a to the negative n is a to the n. In symbols, this is what those words mean. So if I have a to the negative exponent, I have to flip it to the denominator to make it positive. And vice versa. If I have a negative exponent in the denominator, if I flip it over my fraction and raise it to the numerator, it becomes positive. So whenever we write our final answers, we will not write them with negative exponents. So we have to remember we have to find the reciprocal to get that negative exponent positive. Let's look at a few examples. 2 to the negative 4th exponent, if I make that negative 4 positive, I would have to flip it and put that in the denominator. So 2 to the 4th power is really 1/16. So 2 to the negative 4th is really 1/16. And we're going to leave all of our answers in fraction form, no decimals. 1 over j to the 4th would be j to the 4th. 1 over j to the negative 4th turns into j to the fourth in the numerator. Then this third one here, I am going to circle everything that I need to flip to make positive. So that would be the r to the negative third and the u to the negative fifth. And then my coefficients, those can be negative. I just need to simplify those as if they were a fraction. So if I take a 5 away, I'm left with a negative 4 in the denominator. And then if I bring those u's up, I have u to the positive fifth exponent. And then if I bring down 3 r's, I already have 2 r's in the denominator, so I combine them and I really add the exponents. And so I get r, I have negative 4 there. I get r to the positive fifth. And then t to the fourth over t to the seventh, if I take away 4, I'm left with 3. So t to the third in the denominator. And that would be my answer for number 3. Let's go through a few more examples. Number 4. I need to simplify here using only positive exponents. So I'm going to first simplify, take away or divide by 2. So I'm left with 1 in the numerator and 5 in the denominator. And then if I bring up 3 a's and I already have 2, I get a to the fifth. If I bring up that b, I get b to the fourth. And now I have to flip both c's. So what I get is c to the fourth in the numerator over c to the fifth in the denominator. So if I take away 4 from the numerator, I'm just left with 1c in the denominator. So my final answer would be a to the fifth, b to the fourth, all over 5c. Okay, number 5 has a lot going on, so I need to distribute the 2 to everything inside the parentheses. So it goes to the 4, a to the negative third, b to the second, c to the negative first. 7, a to the fourth, b to the negative third, c to the negative second. So now I'm going to write out everything that I have here over to the right. I'm going to give myself some more space here. And then what this looks like is 4 to the negative second. So to negative 3 to the negative second would be negative 3 times negative 2, which is positive 6. B to the negative fourth. And then c to the second, all over 7 to the negative second, a to the negative eighth, b to the positive sixth, and c to the fourth. Now I'm going to circle everything that I'm going to need to flip. So that will be even my coefficients here. Those have negative exponents, so those have to flip. And so when I flip everything here, I end up getting 7 squared. And then I have 8, I already have 6 in the numerator, but I bring up 8. So a to the 14th, and then c squared, if I take away 2 there, I'm left with c squared in the bottom. And then b's bring down, so there's none left in the numerator. But I had to bring down the 4 to the negative second, so that becomes positive 4 to the second in the denominator. Then I brought down 4 more b's, adding to the b to the sixth, so b to the 10th. And now I'm going to simplify actually right over here. So 7 squared is 49, a to the 14th, all over 4 squared is 16, b to the 10th, and c squared would now be my final answer. And I would look to try and simplify 49 over 16, but nothing goes evenly into 49 and 16, so this would be my final answer. We are now going to talk about order of magnitude, which will lead us into scientific notation. But order of magnitude means the number rounded to the nearest power of 10. So for example, thousands is 10 to the third, which if I write that out would be 1,000. Million is 10 to the sixth, which means I have 6 zeros. Similar to thousand had 3 zeros following. Billion has 9 zeros. So 10 to the ninth. And trillion is 10 to the 12th. So I'll write 12 zeros. And just a question, but do you know what comes after trillion? Quadrillion, then quintillion, and it will continue on with certain prefixes. 95 trillion is closest to it if we rounded. 100 trillion. So its order of magnitude would be 10 to the 11th because it has 11 zeros. So let's take a look at a few word problems that involve order of magnitude. An adult human weighs about 70 kilograms. And an adult dairy cow weighs about 700 kilograms. The weights differ by what order of magnitude? Well, we can express 70 kilograms as 7 times 10 to the first. So 10 to the first because it has one zero. And then for the 700 kilograms, that's 7 times 10 to the second. So 10 to the first and 10 to the second, if I divide those, 10 to the first over 10 to the second, over 10 to the first, we would really subtract the exponents here. And I'd be left with 10 to the first. So these weights differ by an order of magnitude of 10 to the first, which is just times 10. So think about it, 70 times 10 gives me 700. So that's what order of magnitude would represent here in this problem. Thanks for listening. Have a great day. Bye.